Hey everybody, welcome to Tech Talk Education. This is Dr. Heldman. This is another movie in a series of movies that I've been creating regarding how to create a Linux cluster environment. In this movie, we're going to go over a little bit more advanced code. This is C code that I want to explain to you. We're running MPI code. We're going to use Visual Studio Code to write this code. And I want to explain how it works. And the idea behind this is that we're trying to figure out how these nodes talk to each other in between inside this cluster node environment. This, and there will be one other piece of C code that I'll do in a different movie, and then we'll move on to a little bit more expansive use of this type of technology in another movie, and then we'll be done with it. So let's get started. This should be informative and useful and fun, and I hope you're enjoying these movies on how to create a Linux cluster node computing environment. Okay, so I've done the standard stuff. I've got master node up and running. I've got compute node new 1 up and running, and I've got compute node 2 up and running. Everything looks good there. I have pinged across each of these to make sure that I can connect to them. And I have done the standard sudo apt update and sudo apt upgrade, just to make sure everything's up to snuff for the day, the work that I'm going to do, TAC-Y. So I've already done that on all the nodes. I've pinged all the nodes by name and by IP address. Everything looks good. I can get around through here. And now we're ready to write some code. Now the purpose of this code is to teach you the terms broadcast and reduce. So broadcast, it means that we have some important data that we want to share to all the nodes. We're going to broadcast the data to all of the nodes. Reduce means that we're going to aggregate that data when we get it back. And we have a variety of things we could do. We could do a sum, we could do a min looking for minimum or maximum, and so forth. So that's the idea. We want to find out about how these broadcast and reduce terms look. Now I'm going to use a Visual Studio here. By the way, I did find out, I had in a previous movie where it would come up and it would say adjust permissions. I didn't think I needed to because I thought I already had that, but it turns out that I didn't have that. And so I clicked that button. It changed the permissions, and now I've got a desktop icon that comes up just fine. This is the code that we want to write. Now you're getting a squiggly here, and the reason I'm getting a squiggly is because I promised you a movie on how to align VS Code with the MPI libraries, and I haven't made that movie yet, so we're just going to do it natively via the command line. But the reason I'm using VS Code is it's a good IDE, and it brings me a lot of extra information like the line numbers, the coloring, and so forth, so it's a little bit easier to read the code. So we're going to include mpi.h, that's a header file, stdio, that stands for standard io.h, which is very, very normal. That's what's allowing you to do this printf function right here. And then we start out. Now we have some, you're going to have to get used to the MPI functions. There are quite a few of them. The first one is init, and of course all this does is get the entire cluster node, all of the nodes ready to go, ready to cooperate together. Next we grab the rank. Now what the rank means is it's the rank of the workers. I like this term. So master node you could call boss, compute node 1 and compute node 2 you could call workers. So that's sort of a layman's notation of that. I like it a lot because it's friendlier. So what we want to do is get the rank of the workers. And of course master node is 0, compute node 1, its rank is 1, compute node 2, its rank is 2. And then we want to get the size. Now in this case, I only have 3 nodes, master node, compute node 1, and compute node 2. So my world size is going to be 3. So we're just getting those. Also, you remember that when we have a variable like world rank here, what we're doing is we have a holding place in computer memory here, and we refer to it as world rank. The computer refers to it as a hexadecimal memory address. It's really not hex, it's binary, but it's represented to us in hexadecimal. So we're telling the computer here go to the address of world rank, go inside and get that number. And we are dereferencing this. We're going inside and getting the data out of world rank, and we're doing it for world size as well. So we query the rank here. I hope you can understand what this is doing. This function is saying, how many do I have? And give me their rank. Excuse me, it's saying give me their rank, and then size is saying how many do I have, and we're putting those into variables. Next we come down and we create a variable called value. Now I want to point out that C and C++, you have to give it the data type that it's going to use for this particular variable, and in this case we're going to use an integer data type. That is, there are no decimals, no following it. There's no decimal point and no decimal numbers, no fractional number. And so it's going to be a straight integer. We did not initialize this, so what we're going to do, let me undo that. What we're going to do is we're going to initialize it down here. So look at this if statement. So the if statement says if world rank is equal to 0, I'll put a comment here, i.e. the boss, that means that we're going to give value the number of 100. Now what doesn't it mean? Well, it means that if I am rank 2 or 1, I don't get this value. The only value that I'm going to give out of 100 is to rank 0. So we pass the test if we're rank 0. If we don't have rank 0, we don't pass the test, and then we're going to print out this phrase right here, and it's going to extract it out of value. Should show us 100. The next thing we do is we're going to do a broadcast here. Now broadcast means that we're going to send this to all of the nodes in the cluster environment. What are we going to send? Well, we're going to send value. What is the value? Well, the value is 100. Now again, we're dereferencing this variable. We're going to value, saying go to this memory address, 100's inside here, give me that, and bring it back. That's what's happening, and we're using this ampersand as a dereference operator. And it's going to be an integer. We're telling it that we're going to force this to be an integer, and we're going to give it to the world. So we're going to broadcast this thing to all 3 of the nodes. Imagine if this was, say, 100 nodes or 1,000 nodes, it would instantly broadcast that to all of these nodes. So it's very, very powerful. We're just looking at it at a very scaled down level. The next thing we do is declare a local value variable. And what this is going to do is it's going to take our rank and add 1 to it. Let me show you what that might look like. So I've just taken and drawn this. I'm using mousepad, just a little text editor to keep track of what's happening here so I can show you the values that are going on here. I'm going to move it out of the way of the code a little bit. I'll wind up moving this around a little bit more just as we get down below into the code. But the idea here is that we set world rank of 0 to the boss, world rank of 1 to the worker, world rank of 2 to worker 2. Then we say, okay, we come in here and look at this. What is your world rank? Well, my world rank is 0. I add 1 to that, and so the boss gets the number 1. I rinse and repeat. I do the same thing with process 1, which is compute node 1, and it gets assigned the value 2 because we're adding 1 to it here. We're adding 1 to it right there. And then compute node 2 gets the value 3 because we're adding 1 to it. So that is what that looks like, and that's why we're doing this. And then we declare a variable called global sum, and what global sum is going to do is it's going to add all of those numbers up, and it's going to contain that particular number. So we have the number 1 for process 0, master node, boss, whatever you want to call it. The number 2 for compute node 1 or worker 1, and the number 3 for worker 2, which is compute node 2. We add those up. 1 plus 2 is 3 plus 3, and I put a 7, and that should be a 6 there. 1 plus 2 is 3 plus 3. That should add up to 6. And so that is inside this variable as well. Then what we do is we reduce. Now the idea of reduce is taking everything and bringing it together in some way. And we could do a lot of things with reduction, like we could figure out what the minimum value is, We could do the standard deviation, we could do the maximum value, we could sum it, etc. And in this case, this is a relatively complicated little function to review with all these arguments, but let's go through it. So we're going to reduce something, which means we're going to take a bunch of numbers and reduce it to some value. What numbers are we going to take? We're going to take the local value and the global sum. We're going to require those to be an integer, and we're going to sum the operation together from the world. And then it says if world rank equals 0, that would be the master. Sum of all values from all processes, we're just going to output global sum. Then we finalize and return. Okay, so that's the code. I'm going to go ahead and save that. I'll just do a quick file save, Control S, and kill Visual Studio Code. Now I can take a look out here. If I do an ls, I see that here is my code right here. And you could cat it out if you'd like to, just to make sure that it looks right. This is actually, casting is a really good way to do the, using the cat operation is a really good way to look at text just to make sure it looks good, or if you're given an error, like there's a compilation error, you could say, okay, what does it look like? What did I do wrong here? It's a really quick way of you being able to look at the code and see what it's doing. So what we want to do now, we want to compile this thing. So the way that we do that is we say mpicc, and we want to take this MPI broadcast reduce.c, and we want to output it to MPI broadcast reduce. We don't want the .c on there because the .c is indicating that this is C code. What we want now is an executable that we can copy across to the other nodes. So if I do an ls, I see the executable sitting out there. It shows up as green, which means it is natively executable. You could run chmod +x or chmod 777 or whatever you wanted to in order to make it executable, but in this case it already is executable, so we're in good shape there. The next thing that we want to do is we want to copy that to each of our compute nodes. So this is an SCP operation. Now, this is not automated at all. If I was working with this kind of thing and I was using DevOps, there's a technique that I could use to copy this code to all of the nodes rather instantaneously rather than issuing multiple SCP commands. But in this case, because we only have the 2 compute nodes, I'm just going to use SCP. And that is stuff for a later movie for sure. We need to talk about DevOps. So I'm going to copy MPI broadcast reduce, the executable, to bill at compute node 1, colon, and I want to put it into the root of bill there. So I want to put it right there. Now, in times past, I neglected to leave, put on this colon and the tilde 1, and so it would act like it was doing it, but it really wasn't doing it, or if it was putting it in a place I didn't know about. So I found that putting in colon, tilde slash here, lets it go to the place where it needs to go. And I got some good information here. It's telling me that it did indeed copy it over. And if I go look at node 2 and I do an ls here, I can see that I have broadcast reduce. So that looks good. Let's do this one more time. So I'll hit my up arrow and I'll make it go to compute node 2. I'll just back over here and hit enter. That looks good. Let's go to compute node 2. And of course you wouldn't have to do this of a normal day once you were sure everything was working. But I'm just second guessing myself just to make sure everything looks good. Alright, the next thing that we want to do is we want to run this bad boy. Now the way that we run it is I'm going to clear the screen and I'm going to do an MPI run. That's the command to run MPI code. We need to tell it that we have a host file. And our host file is tilde slash, in other words it's in the root directory where I'm currently at, and it's called MPI hosts. And let's tell it that the number of processes we have is 3. And then I'm going to run ./MPI broadcast reduce. And let's see how we do. Beautiful. Okay. Now it did exactly what we expected it to do. There's no surprises here. So we know this is saying that master node was broadcasting a value of 100 to all of the other nodes in the environment. And then when it gets it back, this is the reduction here. So this is the broadcast here. This is the reduction. The reduction is saying, okay, I took all of these and I summed them together. Now we could play around with this code a little bit if you thought we wanted to. So I went ahead and I brought up VS Code again here. Went down and changed this from a sum to a min, which means minimum. And then of course you have to recompile it and re-SCP it to the other nodes, which I've already done, but I wanted to show you the output here that it does indeed show you the min value here that it got back from the nodes. So what we're doing is we're satisfying ourselves that there is definitely, we're on the cluster node environment, we are talking to the nodes, and they are doing our processing with us. Now that's all I have for this one. I just wanted to show you, I wanted to explain in more detail some of these functions, and I will go out and I will copy some of the functions and put them in the movie below so that you can play around with this in addition to just summing and min. There's max, there's others. I'll copy those and put them in the notes for this video so that you can play around with this and get it working for yourself. I hope this has been really helpful. Thank you so much for watching these videos. I super appreciate you guys. You know I'm trying to build out this channel. I really enjoy teaching high-end technologies like this. I enjoy trying to reduce it down to where my tiny little brain can understand it. Other people who are new to this environment can understand it. So I really, really appreciate you sharing this with your friends, liking it, subscribing to it. You're welcome to leave comments on it. I've gotten some really nice comments. And I hope you have a great day, and I will talk to you in the next video.